In this video, we will generate the Taylor-Maclaurin series sum of this function lnx centered at 2, 3, and 4. We begin with the lnx dataset. So array formula ln of the x values. And we continue with the Taylor-Maclaurin series sum, which is equal to y equals the summation of ln c plus the y equals ln c plus the summation of a times x minus c raised to the power n. And the value of c is data validation, list of items, 2, 3, and 4. You can start with 2. And the value of n is from 1 to infinity. We can go as far as infinity, which is, let's say 17 is good enough. Now we complete the coefficient. So array formula minus 1 raised to the power the quantity n plus 1. That's for the numerator. Now the denominator. The denominator has two parts. So the first part is n. Second part times c raised to the power n. C raised to the power n. Now we can complete the series sum expansion. So this is equal to array formula series sum of the x minus c. So x minus c raised to the power n, where n starts from 1 incremented by 1. This is our n. It starts from 1 incremented by 1. And the coefficient will be this range. Continue with the ln c. So series sum. So this is plus ln of c. So ln of c. And close the parentheses. And continue. We calculate the y hat. To do that, we start with the LINEST matrix. So this is equal to array formula of the x values raised to the power 0. So that's the one column. This is the array formula ln of the x values. Just completed the lnx column. Now the PGRN inverse. So inverse and mult transpose of the LINEST matrix and itself. And the PGRN vector, which is a mult transpose of the LINEST matrix and the y values. Our y values will be this. Is the expansion. Now we can calculate the coefficients b0, b1, which is a mult of the inverse and the vector. Now that we have the coefficients and we have the LINEST matrix, now we can calculate the y hat, which is m mult of the LINEST matrix and the coefficients. And we chart this. Insert chart. And we use scatter chart. Remove the title. We don't need the title. And the series to show the trend line. Logarithmic. And you should use the equation as label. For the legend, position at the bottom. And we don't have a yellow, so we change the color, the yellow color to green. This is not, this should be green. So here we have the logarithmic equation and the trend lines. We'll calculate this using LINEST. Begin with the function itself. So LINEST data y and data x. Again, this is LINEST data y and data x. And this is LINEST data y and data x. Okay, let's compare. Coefficient of x to the 0, 0, point, it's 0.0356, 0.0356. This is 0.0356. Coefficient of ln x, that's 1. And this is 1.27. 1.27 is 1.27. At center equals 3. Coefficient of x to the 0, 0. This is 3.73 times 10 to the minus 3, 3.73 times 10 to the minus 3. Coefficient of ln x, 1. That's 1. And this is 0.996 and 0.996. Coefficient of x of 4. At C, center is 4. Center is 4. Coefficient of x to the 0, 0, 1.14 times 10 to the minus 2. So 0.0114, 0.0114. Coefficient of ln x, that's 1. And this is 0.989, 0.989. So this completes the use of the series sum in the Taylor series expansion of the ln c or ln x centered at c from 2 to 4. And also the use of the LINEST logarithmic regression.